because let's go. The set of points where the function is differentiable for this function, right? So it's a square root of 1 minus e power negative x square. So, all right. So its differentiation is just going to be what? And then you got this thing on top, which, okay, it depends actually. Like in one place it would be positive, one place it would be negative or something. We'll see, we'll see. So this will just be what? Negative negative is positive e power negative x square, and then that times of 2x. So this is the derivative negative x e power negative x square of 1 square root of 1 minus e power negative x square. So where is this differentiable, right? This will of course be differentiable in the, so whenever this thing is positive, of course, right? Yeah, I mean, like, this is actually positive all of the time. Wait a second. What's the derivative of square root of x? We say it's 1 upon 2 square root of x. Uh, and that assumes that this thing is positive, and yeah, okay, it's not problematic actually. This is still fine, no big deal. So wherever this is defined, you can do it. Okay, so where is this differentiable? That will happen whenever this thing is not 0. Then it's differentiable, right? And when is this thing 0? That will happen when 1 minus, so like 1 is equal to e power negative x square. It just means negative x equal to 0, so x equal to 0. That's when that happens. So everything except 0, that should be b, I think. So at b it's not differentiable. Next question, 42. Oh, and of course, like whenever this is negative, that's a problematic thing as well. But when is this inside thing negative? That is less than or equal to 0, right? So, okay, and when it's differentiable, of course, this must be positive. Otherwise, it doesn't actually make any sense. So this must be positive, which means e power negative x square should be less than 1. So negative x square should be less than 0, which is obvious, right? This happens. So yeah, that's the thing. Next question. This function is e power negative mod of sin x. It's continuous everywhere, but not differentiable, whatever. So, okay, mod of sin x, that's a problematic thing. So it contains signum of sin x and not nice, but whatever. So this thing is like e power negative sin x times signum of sin x, right? So the differentiation of this thing is like e power negative all of this stuff, which is like mod of sin x, of course. The derivative of this thing, which is negative cosine of x, and that times of signum of x. Sorry, signum of sine of x. So this is going to be the derivative wherever your signum of sine of x is not changing, right? And of course, in only those cases can you actually do anything. Otherwise, yeah. Well, I'm interested in what is the differentiation at x equal to 0, because that is right, or points like that where sin x actually goes to 0, right? I want to see what happens in those cases. Whatever, we'll see. So this is the derivative. Okay, this is of course continuous. That's good. So at points where sin x is changing from, let's say, negative to positive, um, this part will still be the same thing, but then this part, so it's first it's like negative, then it's positive, and then the thing is like this is just negative 1 because sin x equal to 0. Okay, plus minus of 1, right? But the thing is it's not 0. Similarly, this thing is not 0 because e power 0 is just 1, right? So yeah, it's actually changing from negative 1 to positive 1. So the limit does not exist, which means it's not differentiable wherever sin x is 0, that is at n pi. So it is continuous everywhere, but not differentiable at x equal to n pi and belonging to integers. Yeah, that makes sense. Next question. 43. 43 is, if f is this thing, then f is so square root of 1 minus square root of 1 minus x squared. Okay, so first of all, it's domain, right? So what should happen is that 1 should be bigger than square root of 1 minus x squared, which of course means 1 is bigger than 1 minus x squared. So 0 is bigger than negative x squared, which obviously happens by itself. It should actually be bigger than or equal to, but then whatever. And of course, like 1 minus x squared, that should be bigger than 0. So x squared is less than 1, Actually, it should be bigger than or equal to, right? So x square less than 1, which means that x belongs to -1 to 1. So this is the domain, right? Yes, it is continuous on that domain. I get that. And yeah, because its square root is the positive square. Wait, okay. Yeah, that is the thing. In fact, it is continuous. No big deal. So yes, it's continuous on that, but is it differentiable on that or not? So the derivative, whenever it exists, is just this thing 1 upon 2 square root of 1 minus 1. Okay, all of that stuff. Right of the inside stuff, which is just let's see. First of all, you got -1 upon 2 square root of 1 minus x squared, and then a bit of the more inside stuff, which would just be -2x. Because yeah, that looks good. So this will just be what? It will be x upon square root of 1 minus x square, and then you got square. Okay, that 2 is also this 2 square root of 1 minus x square. So at points wherever this is going to become 0, like those are problematic, right? Those are problematic points. So whenever x is equal to 0, it's a problem, because then this thing is going to be 0, which yeah, it's a problematic. uh, Although you have this over this, maybe we'll just able to rationalize in something. So let's try it out. Who knows, it might work out. Yeah, okay. So we'll multiply by this thing, square root of 1 plus square root of minus x squared, and then similarly over here as well. Yeah, and this will just become what? So it's 2x square root of 1 plus square root of 1 minus x squared upon square root of 1 minus x squared. And this thing just becomes square root of 1 minus 1 is 0, and then it's just x squared. It's like, yeah, square root of x squared is just mod of x. Uh-oh. Yeah, that's problematic. It's mod of x. Huh. That was not expected. Which means that over here you're actually going to have 2 signum of x. Huh. Well, that was bad. Uh, okay. So at x equal to 0, what is happening? This is approaching what? This is approaching 2, this is approaching 1, but then signum of x is not approaching anything. Like, it changes from -1 to 1 as it crosses 0, right? So that means at 0 it's not differentiable, because negative of some non-zero quantity and then positive some non-zero quantity, limits don't match. So it's not differentiable on 0. Okay, it is continuous on the whole domain. um, where else is this not differentiable? Is it differentiable at x equal to 1? Because that happens when, yeah, okay. So when x is equal to 1 or -1, this thing just becomes problematic, right? It just becomes 0. Well, this approaches what? So get rid of these things. This approaches just 1. This also becomes 1. But then this thing, yeah, it just becomes 0. So not defined, right? It's not differentiable at -1 and 1, which means you don't put those in the interval. So yeah, this is the thing. -1 comma 0 to 0 comma 1 round brackets. So B is the answer. Next question. Oh, okay. In fact, the thing is, how would you even define the derivative at, okay, so you will have to take just one-handed limit to get the derivative, right? Once again, that actually approaches infinity, so whatever. Just B is the answer. Next question. So it's continuous and differentiable except at 0 and plus minus 1. Okay, 44. 4 is that f be a function differentiable at x equal to c, then the limit as x tends to c of f of x is. Okay, extends to c. I mean just f of c, right? It's a differentiable function. It should be continuous as well. So of course it's just f of c. What are we talking about? No, none of these. Why would it be f dash of c and what? So yes, it's a function differentiable at x equal to c. I get that, but how does this limit do anything? Like it doesn't give us any of these things. It just gives us f of c, right? I don't know. That doesn't look correct. It should be f of x, not f dash or whatever this thing is. And no, it cannot be 1 upon f of c. That would be not correct. For example, just take. Why do I even have to give an example? Just none of these. 45. This function is not differentiable at, okay, small of x minus 2, factorize this thing, x minus 2 and then x plus 2, I think. It doesn't matter because it's a polynomial in any case. So just x square minus 4. Then this thing inside the mod is what? Where did that go? Yes, it's just x minus 1 and x minus 2, right? Okay, and we want what? The differentiation of that. And then just cosine of mod of, that's the same thing as cosine of x, because it doesn't matter whether x is positive or negative, you're gonna give the same value. So yeah. So yeah, I mean, this is differentiable infinitely. This part is differentiable, except that this part is kind of weird. So in the range 1 to 2 and 2 to infinity and negative infinity to 1, like in those open intervals, this is differentiable because it's just a polynomial function plus cosine of x, right? But when we are changing, so we are going from one range to other, it might be not differentiable. So at 1, at 2, right? Um, so at 1, what would be the differentiation? Okay, it's like plus minus, and that changes. Actually, it should be this thing, x square minus 4, whatever this thing is, plus minus x minus 2. We don't care about it. This is just a polynomial. We don't care about it. Okay. Yeah. Wait, okay, this contains x minus 2 as well. That's a problematic thing. If fine, but at least let's just do it for x minus 1, right? Okay. Now this is signum of x minus 1 and that times of x minus 1, right? Yeah, okay. Maybe this is not how it should be. Some other way to be doing it. Come on, think about it. Like, you are just gonna take a derivative, so derivative of this complete polynomial function, and put something inside it. We won't get 0, that's important. And that times of this thing, it's you put mod of x minus 1 because we don't really care. It's just mod of x minus 1. So the derivative of this guy times, yeah, that 0, right? But then when you take the derivative of this thing, it has two different definitions, and then yeah, okay, it's plus minus 1. That makes sense, right? So it's plus 1 on one side and minus 1 on the other side. And when you put x equal to 1 in there, right, this thing, it doesn't actually become 0, which means that it's not differentiable at x equal to 1. What about x equal to 2? For x equal to 2, it's a different case, because now, of course, when you will take the derivative of this guy and you will put x equal to 2 in that term, it's gone, it's just 0. But when you will take the derivative of this term, right, and you will put x equal to 2 in the whole thing, so this will be gone as well, because x square minus 4 becomes 0. What does that mean? That just means it's actually differentiable at x equal to 2. All right, so this is not differentiable at x equal to 1. Yeah, 45th C. Next question, 46th. And I would suggest just do this question by yourself. Like, actually take the piecewise definitions and then see how the differentiation works out in each case and see how it's changing at 1 and 2. You will see what happens. Okay, 46. If f of x is equal to this thing, then f of x is, so it's x square e power negative 1 upon mod of x plus 1 upon x. Okay, interesting. So when x is bigger than 0, this just becomes what? X square e power negative 2 upon x, right? X, so when x is less than 0, this becomes x square, and then, okay, this is e power 0, so it's x square, right? And at 0, it's just equal to 0. Okay, that looks cool. So now what do I have to do, by the way? What do we have to do? Oh yeah, then f of x is continuous differential. Okay, about that, right? Fine. So this limit as x tends to 0, it will be 0. The limit of this thing as x tends to 0, it will be like x square e power negative 2 upon x. Okay, it should be 0 plus, right? As x tends to 0 plus. So 2 upon x will approach positive infinity. So just e power negative infinity, which becomes 0. And that also 0 once again. So yes, it's going to be 0. So it's continuous at least. What's the derivative of this thing though? Because, right, so When x is less than 0, the derivative just becomes 2x, right? Approaches 0. Cool. This doesn't make sense because it's just a single point. The derivative over here, okay, you will just have x square e power negative 2 upon x, and then the difference, that guy, which is what? Negative 2 upon x square, okay, fine, just 2 upon x square, right? So it's just this thing, 2 e power negative 2 upon x, and then this thing, so like plus 2x e power negative 2 upon x, and then yeah, like this approaches 0, this approaches whatever. The thing is, it just approaches 0, right? So this becomes 0 at x equal to 0, and this becomes 0 at x equal to 0 as well. I mean, the derivative of that thing, of course. So yeah, it's differentiable as well. Oh yeah, like it's just differentiable at x equal to 0. Yeah, so at all the other points, it's of course differentiable because this thing is like well defined for all the other points. So what does that mean? There you go. It's just continuous as well as differentiable for all x. So A is the answer. Next question, 47th. The seventh is the function f of x is equal to x cubed sine square of 1 upon x. X, what is this thing? Is not equal to 0. F of 0 equal to 0 and x equal to 0 is. The function is x cubed sine square of 1 upon x. Fine. F of 0 equal to 0. Okay. Oh, so when x is not equal to 0, it's this thing. And f of 0 is 0. And at x equal to 0, it's of course continuous. Its differentiation, I mean, we just have like 3x squared times this stuff, and then you'll have x cubed times the derivative of whatever this thing is, which will contain a negative 1 upon x squared, and otherwise it's just random things that we don't care about. It's just finite random things, so that's why we don't care about them. And then the negative 1 upon x squared, no match for x cubed. It will still overpower it, which means that it goes to 0. So the derivative goes to 0, right? So yeah, it's like continuous and differentiable at all points. Yeah, yeah, that does make sense, right? I guess so. There we go. So it's differentiable. See, next question, 48th. Wait, okay, come on. If something's differentiable, it's already continuous. Why do you even give me C and D in different? Okay, so it should be D. But then really, C and D are the same things because for a function to be differentiable, it should be continuous. Anyway, next question. So the following is not true. An algebraic polynomial function is everywhere continuous and differentiable. Well, yeah, polynomial functions, right? Yes. A continuous function is always different. No. Take mod x for example. A differentiable function is always continuous. Yes, that's right. Modulus function is not differentiable at its zeros. It's only 1 0 for that. Modulus. Oh, so you mean like the modulus of a polynomial, I think, or something like that. Yeah, okay, that looks correct a bit because last time we saw that it was differentiable at 2 because it contained another term which was not in the mod. And, well, whatever. I mean, yeah, like D is, it depends on what function you're talking about, right? But D modulus function, so mod of x, well, that function is, so that has only 1 0, which is 0. And yeah, it's not differentiable at that point. Sure, that makes sense. So there we go. That works out. What was I doing once again? Right. So which of the following is not true? B. Continuous function is not always differentiable. 49. F of x is this thing, signum of sine of x. Then f is continuous but not differentiable at 0. So right after this thing is just, yeah, okay, fine. It's like 1 over there, it's negative 1. And no, it's not continuous in the first place. It's not continuous. It has jump discontinuity, of course. So at x equal to 0, exactly this is 0. At x slightly more than 0, this is 1. Slightly less than 0, it's negative 1. So it's not continuous in the first place. Next question, 50. Not just at 0, but at any integral multiple of pi, it works like that. It's just discontinuous. A function is this thing, okay, discontinuous at x equal to 2, continuous and whatever. So you want x equal to 2, what's happening, right? Okay. So it's 1 plus x. We should draw this out. Of course, it's not differentiable because these two slopes are different, but just put x equal to 2 and there is 3 and that's also 3. So it's continuous, sure. but it's not differentiable because it's slope 1, slope -1, right? I don't even need to draw it out for that. So this is continuous but not differentiable. C. Next question, 51. Let f be real to real function given by, okay, what? Be a given function, but they didn't actually give me the thing. Fine. G, so from real to real. So that's given by g of x equal to mod of f of mod of x for all x, then g is, oh, seriously, what? Okay, mod of f of mod of x. I mean, it contains mod of x, right? And it works for all real. I mean, of course, that's its domain, right? So yeah, uh, right, which means it's definitely not 1, 1 because you can put a positive x and a negative x and it will still give the same value. So it's not 1, 1. Uh, so no, it can never be 1, 1. Is it differentiable? If f is differentiable, depends on what f is, right? Continuous, if I, yeah, that I agree on. If f is continuous, this will be continuous as well, right? But it's just mod, right? It's just taking a mod of it. It isn't doing anything problematic, right? Onto, if f is onto, no, there could be a problem with that because you're taking the mod. So and the uh, the codomain is all real numbers. So what about the negative real numbers? It's not covering the whole codomain. That's why it can never be onto. So only C is the correct option. Next question, 52. Differentiation. Okay. Wait. Oh, okay. That was differentiability. And now, seriously though, why are they making us do derivatives over here when we are learning about continuity and differentiability? I don't know. Okay, if f of 4 equal to 6, then f dash of 4 equal to 1. Okay, then limit as x tends to 4 of this thing is fine. It's x f of 4 minus 4 f of x upon, so like x tends to 4, right? Okay, so just say x is equal to 4 plus h, then this just becomes what? 4 plus h. Oh, okay, I see what's happening. Look at this. I mean, just look at this. This is x f of, okay, this is kind of different what I thought it would be actually. It's x f of 4. Huh. What if I take 4x out, right? Then you just get this thing 4x f of 4 upon 4 minus f of x upon x upon, you know what, just take another negative out as well, just have 4 minus x. So now that looks like a, yeah, now it looks like a derivative because this is the difference between the two x values and this is the difference between two y values where you have just y equal to f of x upon x, right? We're taking the graph of this curve. What am I saying? The graph of this function, right? Then this looks like a derivative at x equal to 4, of course, because x approaches 4 in any case. So yeah, this is just what, negative 4 times of 4 and then you got f, okay, not say it's like this thing, d upon dx of f of x upon x, this function, and you evaluate it at 4, right? Okay, what will this be? So this will just be what, f dash of x upon x minus f of x upon x squared. So when you will put x equal to 4 in this thing, it just becomes f dash of 4, which is what, 1, and then upon 4 minus f of 4, which is 6 upon 4 squared, and that times of 4 squared actually, negative, sorry. Okay, so negative 4 squared times this thing, which means it's just negative 4 plus 6 times 4, which is 24, right? Yeah, it should be 20, and that's not here. Did I do something wrong? So it's not squared over there. I mean, clearly just derivative, right? I took that out, 4x out. This should have been a 4 upon 4. Well, yeah, that should be the thing. So why did it not work? No, how could it not work? It should have worked. It should be 20, right? Oh, sorry, it's okay, that's where I went wrong. This is negative 4, right? Plus just 6, just 6. So this is 2. Yeah. So the answer is B. Next question. 53. 53 is if f of x plus 2y is equal to 2 f of x f of y. Oh, wow, rather problematic stuff. Okay, for all x and y, and f of 5 is equal to, right, whatever. Just have to figure out what the function is. Oh god, that's not looking good. uh I could always put x equal, I could always put y equal to 0, right? What does that tell us? It just tells us like f of x is equal to 2 f of x times this f of 0, right? Of course. So 2 f of 0, that must be 1. So f of 0 equal to 1 upon 2. We know that right away. Okay. Let's try to differentiate and something. Well, yeah. That is assuming it's actually differentiable, but then they are already assuming that because f dash of 0, f dash of 5. So just assume it's differentiable. What does that tell us? F dash of x. I'm just taking a partial with respect to, let's say, x, right? So we'll have this thing. That's just equal to what? 2 f dash. Oh, come on. Maybe it's like it has some other way of doing it. Or, ah, it's just weird actually. What I was thinking is, what if I put x is equal to y or something like that? And no, okay, just do it. Just do it the proper way. So 2 f dash of x times f of y, because it's a constant with respect to x, right? Okay. Now what? Let's just say put y equal to 0, right? So we just have f dash of x. And you could also have some other, wait a second, doing the other equation. Okay, no, that would be a different thing actually. So not exactly the same. Huh. Fine. Then, you know, let's put y equal to 0. What you will get is f dash of x. That's just equal to f dash of x. That's not interesting. Okay. Let's put, I don't know, x equal to 0. Wait, if I put x equal to 0 in this, I will just get like f dash of 2y is equal to, so like 2f. Okay, I don't know what f dash is. That's a problematic thing, isn't it? Ah, this could have worked though. You know what? No, just put x equal to 0. We don't care what's gonna happen. Actually, first of all, we'll take the partial with respect to y actually, because that is a better thing to do. So we'll just have this is equal to 2f of x times f dash of y, and now you will put y equal to 0 in this thing. So what that gives us is just that 2 is actually gone. It's just f dash of x is equal to f of x times f dash of 0, right? uh yeah, so like natural log of f of x is equal to f dash of 0 times x plus some kind of constant, whatever. So f of x is just equal to some constant times e power f dash of 0 times x. That looks cool. Yeah, so that's our function. And let's just write it like this: a e power, what is this, ax or something. Doesn't look good actually. Oh, okay, so a should be 1, because, right, a has to be 1, because when you take the derivative, actually what will happen is that f dash of x will just become what? A f dash of 0, and then you will just have e power f dash of 0 times x. So when you put x equal to 0, you just get this thing: f dash of 0 is equal to a f dash of 0. Now if f dash of 0 is 0, then this makes no sense, because f is just some kind of constant, right? Yeah, it would just be some kind of constant. But then what kind of constant works? X is equal to 2x squared, just x equal to 0, or x is equal to 1 upon 2. So the, I should say a, right? So the constant a, that will be 0 or 1 upon 2. So either it's the 0 function or it's the constant 1 upon 2. But in both cases, f dash cannot be. Oh, you already gave me f dash of 0. You should have told me. Wait. Okay, a equal to 1, that we know at least, right? So f dash of x, oops, not f dash, f of x is equal to e power f dash of 0 times x, which is just e power 3x, because f dash of 0 is given as 3x. This is our function. Yeah, that looks cool. So like e power, let's just say e power 3 is a, then just like whatever b or whatever you want to call it. So b power x, right? Where b is e cube. So we'll just have b power x plus 2y is equal to 2 times of b power x times, wait, no, that's weird. Something went wrong. But this should have been an exponential function. That's what we got, right? Uh, so where does this 2 come in? Why is there a 2 involved in there? Are we sure a is 1? Did I mess up somewhere? F dash of 0 is equal to a f dash of 0, of course. So a should be 1. But yeah. Okay. Interesting. Wait, but if a is 1, it's like that just means f of x is equal to this thing. It's just some kind of exponential function, but then what exponential function even works over here? You're having 2 f of x times f of y, right? No, something's just wrong. What was the thing once again? Sorry. This was f dash of 0. Yeah. Now we are getting this thing. So only one way this could work, right? A equal to 1. What other choice do you even have? But then if you actually put a equal to 1, everything goes wrong. Oof, this is not going good. Something must have gone wrong. What went wrong exactly? Equals to y. Okay. So 2 f of x times f of y. Okay. Interesting. This should really have been like f of y squared, then this would have worked because, come on, think, p power x plus 2y, is that actually equal to 2p power x and then that times of p power y, which is like this thing actually? No, it's not. It's not. Something went wrong in our derivation, but then what could have gone wrong? Or maybe there's just no function that actually does this thing. Maybe that's the case, right? But okay, there's of course the zero function, but then that will not satisfy these things, right? So what other functions work? Okay, think. And then I put y equal to 0. So f dash of x is equal to f of x times f dash of 0. So then this means like natural log of f of x is equal to f dash of 0 times x plus one of constant. Yes. So e power that stuff, right? E power c, just say another constant capital A. So f of x is just equal to a e power f dash of 0, that is of x, right? So when you will actually take the derivative, what you will get is f dash of x that's equal to a f dash of 0 and then e power whatever this thing is. So when you will put 0 in there, all you get is just this equation, which of course means a equal to 1 because f dash cannot be 0, otherwise this wouldn't make any sense. And problem is, if a equal to 1, then you'll just get like f of x being equal to some kind of exponential function, but no exponential function satisfies this equation. There's only one way that this could be done, which is that f dash of 0 must be 0, right? That's the only way. Yeah. So if f dash of 0 equal to 0, what that means is, um, okay, that a can be anything and it just becomes like f of x is equal to some kind of constant. Oh, that should have been the thing. F of x is some kind of constant. Only that would work and we can actually figure out what that constant is. So the only way this would work is if f of x was a constant. Huh. Isn't that weird? I don't know. How is it that there's no function that actually satisfies this? But that's what we are getting. There's no differentiable function that satisfies this thing, right? Oh, so there's no such function. That's what we got. So we'll see no such f exists. Okay, 54. Or I could be going wrong somewhere. I don't know. Whatever. Next question. If f of 2 is equal to 3, f dash of 2 is equal to negative 2, g of 2 is equal to negative 1, f dash of 2 equal to 4. The limit is extends to 2 of g squared of x, f squared of 2 minus f squared of x, okay, is equal to. I'm starting having second thoughts about this thing, that maybe there was some function, but maybe in the complex number case or something like that. No, that can't be. I mean, everything we did, it was just using symbols. We were not dealing with actual numbers anywhere, which means that our derivation was also valid for complex numbers, right? A could be a complex number, right? Your f dash of 0 could have been a complex number. We don't care about that. Something went wrong. Yeah. Either something went wrong or that there is actually no such function. Anyway, 54. Let's go to the next question. If f of 2 is equal to 3, f dash of 2 equal to whatever, just some conditions. Then limit x tends to 2 of this thing. Oh, this is interesting. So it's g squared of x f squared of 2 minus f squared of x g squared of 2 upon x squared minus 4. Now it's like the last time. So what you can do is just take out this f squared of 2 and f squared of, sorry, and g squared of 2 outside. So then you will just have this thing. Uh, wait, not g. Okay, no, that's not what you should be doing. F squared of 2 is outside, and then f squared of x. Take that out outside as well. So then this just becomes what? G squared of x upon f squared of x minus what is this? Minus g of 2 upon f of 2 upon x square minus 4. And just say that g of x upon f of x, that's our h of x or whatever. Then this thing can be thought of as like h square minus h square at x, of course, minus h square at 2 upon x square minus 2 squared. Sorry, it should be 4, right? Okay. Then this can be factorized like h of x minus h of 2 upon x minus 2, and then that times of h of x plus h of 2 upon x plus 2, and we are taking a limit as x tends to 2, right? So this thing actually just becomes h of x upon 2, right? So in the end, what we get is like f power 4 of 2, and then h of 2 upon 2, and then h dash of 2, right? Does that look good? This just becomes that, right? Yes. And then h is just what was that, g upon f, which means this just becomes f power 3 of 2, and then g of 2 upon 2, and then yeah, just h dash of 2. So h is just f upon g, sorry, no, g upon f, which means that h dash will be g dash upon f minus g upon f squared times f dash. So just figure out what h dash should be at 2. So they're saying g dash of 2 is negative 1. So this is negative 1 upon f is just 3. Then minus, what is g? G is negative 1, okay, upon f squared. So that's just 3 squared, 9. And then that's of f dash. F dash is negative 2, okay, interesting. This will just be 2 upon 9. So that's just negative 1 upon 3 minus 2 upon 9, right? Which is basically like negative 3 upon 3. Fine. So just negative 5 upon 9. That's what this h dash will be. So just have, or maybe you should just directly do that thing. Yeah, that would be better actually. Just multiply this by squared, right? So yeah, just fg upon 2. Then this thing just becomes that. So that's like g dash f minus g f dash. And that thing is gone now. So that's just 1, right? And just do this thing actually instead of that, right? Yeah. So now this will just be, the fg is 3 and negative 1, so just negative 3 upon 2 times g dash is 4 times f is 3 minus g is negative 1, f dash is negative 2, so multiply just 2. There we go. That's our answer, I think. Awesome. Wait, why is there a 4? Something went wrong, right? Oh, G dash is 4, right? Why didn't I use that? It should be 4 over there. Yeah, uh, better, I think. Okay, I must have put G of 2 directly in there. That's not correct. It should be G dash of 2. Right, okay, now it's good. So this is the expression that you will get, which is just negative 3 times, well, 2 times 3 is just 6 minus 1. So negative 3 times 5, negative 15. Next question, C. 55. Okay, come on. 55 is if 5 f of 2x plus 3 f of 2 upon x is equal to 2x plus 2 and y is equal to x f of x, then dy upon dx at x equal to 1 is equal to. All right, another functional equation, but now it's not in two variables, it's just in single variable. Okay, y is equal to x f of x. All right, 5 f of 2x. Okay, this is weird. This happens. So you want dy upon dx at x equal to 1. Hmm. So it was plus 2. Okay, think about it. What can we do? I've never seen a functional equation like this. What function would satisfy this thing? How do you figure that out? Of course, you do this thing. Okay. I think I know what to do. So this works, right? This works for all real values of x, I think. So instead of x, you can also put 1 upon x. So just say that f of 2x is equal to u and f of 2 upon x is equal to v. Then what you currently have is just 5u plus 3v is equal to 2x plus 2. But when you will put 1 upon x instead of x, what you will get is 5v, because that will just now become this thing, right? Yeah. Plus 3u is equal to 2 upon x plus 2. So just add them first of all. So you will just get like 8v plus u is equal to 2x plus 4 plus 2 upon x. Okay, which means that v plus u is, what am I writing? V plus u is just equal to x upon 4 plus 1 upon 2 plus 1 upon 4x. Okay, and then similarly just subtract it. So you will get what? V minus u, well, 2 times that actually. That's going to be equal to this minus that, which is 2 upon x minus 2x. So that just means v minus u is equal to 2 upon x minus, sorry, just 1 upon x minus 1. These are the two equations that you can use to get v and u. So v is just the average of these guys. This plus that upon 2. So it's like 4x upon 4 upon 4x, right? Add that is just 5 upon 4x or something. Right, it's like x upon 8. This will just be negative 1 upon 2 upon 2, just negative 1 upon 4. And this is what? Just add that, right? It should be 5 upon 4x upon 2 is just plus 5 upon 8x. This thing is what? This thing is equal to v, and v we defined was just f of 2 upon x. Then subtract, so you just get f of 2x, which is our u, is subtract and then divide by 2, which is pretty much the same stuff. Right, you still have x upon 8, but now you just have 3 upon 2 upon, which is like 3 upon 4. And you can subtract that, so this is a negative 3 upon 8x. Right? So now you just put, instead of 2x, just put x. F of x, or let's just say instead of x, you'll put x upon 2. That makes sense? It's equal to x upon 16 plus 3 upon 8 minus 3 upon 4x. Right? There we go. You got your function f of x. So you just want y, which is equal to x times f of x. Right? So this times of x is just x squared upon 16 plus 3 upon 8x minus 3 upon 4. Right? Then dy upon dx of, okay, dy upon dx at x equal to 1. Right? This will just be x upon 8 plus 3 upon 8. That's our derivative. And x equal to 1. This is just 1 upon 8 plus 3 upon 8. This is 1 upon, wait, yeah. That is the thing, right? Yeah. So this is just at x equal to 1. Am I going correct or not? Something I'm going correct or not. Wow, something is weird. This should really just be x upon 8. It's like 1 upon 8 plus 3 upon 8. It's just 4 upon 8, which is 1 upon 2. So this should really just be 1 upon 2, but that's not here for some reason. Why is that not here? What went wrong? 7 upon 8? How is that happening? Come on, I did everything correctly, right? When I got the equations correctly, subtract, lose that 3 upon 2 upon 6, 3 upon 8, 6 upon 8, short. What's going on? It's 3 upon 8x. Yes, all of that is just correct. So this should really just be x squared upon, that's f of 2x. So you want f of x, which is x upon 16 plus 3 upon 8 minus. Yeah, that's perfect. It's just correct. So then, why are we not taking that? What is happening? Now this should just be 1 upon 2. So it's none of these. That's the answer. Next question. 56. The derivative of the function mod of x cube minus 1 at x equal to 1 is, okay. So this is like what? X squared plus x plus 1 times x minus 1 with a mod of that actually. Because this thing is always positive, so you don't care about that. So the derivative, the derivative of this thing at x. Okay, you know what? No, just skip all that. We'll just do it the proper way. So x bigger than 1, then this just becomes x cubed minus 1. X less than 1, this becomes 1 minus x cubed. So the derivative of this guy is just 3x squared, like x equal to 1 is just 3. And this would just be negative 3, right? These are our derivatives. So it doesn't exist. The derivative doesn't exist. Next question. Sorry, 57. What am I doing today? The first derivative of the function, this function with respect to x at x equal to pi is, seriously, okay, log base 2 of 2 power s plus 4. Okay, whatever. At x equal to pi, you are saying, huh? Why are we doing this? Like, okay, this is just x plus 3, in fact, because, yeah, I mean, this thing is just that, right? So this is x plus 3 plus sine of 2x, cosine of 2x is, and then you got cosine of 3x as well. Okay, it's like 1 upon 2 sine of 4x, and that is cosine of 3x, right? So at x equal to pi, this actually just becomes 0. Yeah, and this becomes cosine of 3 pi, which is just negative 1 or whatever. So when you will take the derivative of this guy, that will be gone. But when you will take the derivative of that guy, it won't be gone. You just have 1 from this thing, then you will have plus 1 upon 2. So 4 because you're taking the derivative of that guy. And you just have like cosine of 4x and then cosine of 3x, right? Yeah. So 1 plus 2 times of cosine of 4x at x equal to pi just becomes 1, and this just becomes negative 1. So 1 minus 2, which is negative 1. So that's our derivative. All right. That's our answer B. Next question. If y equal to this thing, then dy upon dx at x equal to 3 pi upon 4 is mod of cosine cube x plus mod of sine cube x. Seriously. Okay, at 3 pi upon 4. So in that range, where is it actually in the quadrants? 3 pi upon 4, it's definitely, okay, yeah, it's more than pi upon 2 and less than pi, right? Of course. So that means our cosine value is negative, sine value is positive. It's just sine cube minus cosine cube, basically. You want the derivative of this guy. Just 3 sine square times cosine. It's negative, positive, positive 3 cosine square sine. Yeah, which is just 3 sine cosine times cosine plus sine, right? Just figure that out. So you want the derivative of this guy at x is equal to what? 3 pi. You know, first of all, just write like 3 upon 2 sine of 2x And this can be done in different ways, like square root of 2 sine of x plus pi upon 4, right? So this just becomes this thing, 3 upon square root of 2. Now let's do it. Sine of 2x at x is equal to 3 pi upon 4, right? Just 3 pi upon 2 basically. So like sine of 3 pi upon 2, that is negative 1. And sine of x plus pi upon 4, so that will just be pi. So, oh, that's just 0. Nice. That is 0 somehow. I was not expecting that. So yeah, the derivative is just 0. Okay, next question. um, if f of x plus, okay, maybe there was some reason for, of course, the AMGM inequality. Okay, this is at its maximum value right now. Yeah, okay, that makes perfect sense. It is in fact at its maximum value. Not the AM, wait, what was it? Not the AMGM inequality, it's the power mean inequality, right? Yeah, which says that the cube root of a cube plus b cube upon 2, that is just bigger than or equal to the square root of a square plus b square upon 2. But guess what? When you put a equal to mod of cosine x, b equal to mod of sine x, this is just what y is like. Yes, cube root of y upon 2 is bigger than or equal to square root of, okay, all of that stuff. This just becomes 1, right? Yeah, just 1 upon square root of 2. So what does that mean? Y upon 2 is bigger than or equal to 1 upon 2 square root of 2. And then, so yeah, and this thing y equal to 1 upon square root of 2 happens when these two things are equal, which basically means at 3 pi upon 4, of course, and at pi upon 4, and at all of these different things. Okay, next question. Okay, ninth is done. Oh, we're doing it. So log is x of log of x. Okay, it's like natural log of x. Actually, no, natural log of x upon natural log of x. That's the thing, right? That's what f is. Okay, then f of x at x equal to e. Seriously, what is this? Why are you making me do these kind of things? What? Why? It just like plug in the value, get. Why am I doing this? This is like what? Natural log of natural log of e, which is of 1 basically, 0. Okay, when we are saying log, that definitely means log of, like log base e, right? I guess. So log base e of e is just 1, and then log base e of 1 is 0. So it's supposed to be 0. It's none of, yeah, none of these. I guess they were trying to ask f dash of x or something, but then they wrote f of x. It's their mistake. If f is this thing, then for x is not equal to 1, f dash of x equals, it's more of ln of x, huh? X not equal to 1, f dash of x. Right. Okay, I see what's going on. So when x is bigger than 1, then this just becomes natural log of x. So derivative of that would just be 1 upon x. So add x equal to 1, just 1. When it's less than 1, then this just becomes negative natural log of x. The derivative of that thing just negative 1 upon x, which is negative 1, right? So there's no f dash, it doesn't exist. Oh, okay. You mean like for x is not equal to 1? Oh, you should have told me. So it's 1 upon x if x is bigger than 1, and it's um, negative 1 upon x if x is less than 1, right? So is it this? Okay, no, no, no. It should be this thing, 1 upon x, and then you got signum of whatever this thing is, like 1 minus x. No, x minus 1, I think. Yeah, this should have been thing, right? And it's not here. So none of these. Next question. 61. Derivative of this thing. What is this? Natural log of e power x, x minus 1, whatever. I think these are not fractional parts, right? Just brackets. Yes. This is equal to, of course, we just break it. It's x plus natural log of x minus 1 upon x plus 1, right? Or, okay, break it even further. Natural 1 x plus natural log of x minus 1 upon That's just a negative natural log of x plus 1. Sure. So then what do you want to do? Rate of this guy, just 1 plus 1 upon x minus 1 minus 1 upon x plus 1. So do the thing is just x, and then that like just becomes 2 upon x square minus 1. Yeah. Do we really have to do that though? Rate of this thing, right? Yeah. Where is it? Oh, it should not be x, it should be just 1. Sorry for that. It should just be 1 because yeah, look at that. It's supposed to be 1. Then it just becomes what? X squared minus 1 plus 2, which is x squared plus 1, and that upon x squared minus 1, which is C. Next question. 62. If x is equal to what? E power tan inverse. Okay, fine. dy upon dx at x equal to, right? It's just very weird. Tan of x is equal to e power y upon x minus 1. That's what they're saying. Um, which means like natural log of tan of x is equal to y upon x minus 1. And what do you want at x equal to 1, right? So tan of 1. Uh-oh. Wait. I mean, it's positive, sure. So it's still good for natural log. It's going to be negative. That's the only problem. Whatever. Doesn't really matter. So y is just this thing, x natural log of tan of x plus x. Yeah. You want dy upon dx equals at x equal to 1. It's just what? So 1 plus derivative of this guy is natural log of tan of x, tan of 1, basically, because x equal to 1 at that point. Plus x, and then the derivative of this thing is just 1 upon tan of x times the derivative of tan of x once again, which is just secant square of x. Right, and when you put x equal to 1, it just becomes 1 secant square of 1 is like, okay, sine square upon cosine square, and then you got sine upon cosine or something like that. Come on, seriously. That is not, okay, just 1 upon cosine square, s upon c, this cancels, 1 upon sc, right? Okay. So just 1 upon sine of 1 cosine of 1, right? Okay, that's what this term is. So just 1 plus natural log of tan of 1 plus 1 upon sine of 1 and then cosine of 1. I messed up, didn't I? Sure. Oh, I switched these tan inverse and e value. Okay, okay, okay. I switched the order of the functions. Fine. So this went wrong. Really, really bad. Okay. This should have been this natural log of x is equal to tan inverse of all that. So like tan of this guy, that is equal to y upon x minus 1, which means y is just equal to x plus x, and then you got tan of natural log of x. Cool. Now finally just take the derivative of this guy. It should be 1 plus, okay, tan of natural log of x plus, okay, what, x upon, wait, tan, right, the secant square is like secant square of natural log of x, and then inside, so just 1 upon x. This cancels, it's just this thing, right? It's just this, so like 1 plus at x equal to what? 1, this will be 0. Just 1 plus tan of 0, which is 0, okay, plus, well, that's gone somehow. If it was not gone, then this would be problematic, right? Yeah. And then you just got natural log of x, which is 0 plus second sort of that is 1. So 1 plus 1 is just 2. That looks cool. So 2 is the answer, no? Next question. If y equal to this thing, then dy upon dx is secant inverse of this thing plus sine inverse. So it's like this thing, right? Cosine inverse of, so, okay, so the inside stuff, just call it like a, whatever. The sine inverse of 1, sorry, sine inverse of a, right? What? It's just pi upon 2. Anybody knows that. So yeah, dy upon dx is 0. Yeah. Next question. 64. Tan inverse cosine x plus okay, whatever. 1 minus tan of x upon 1 plus tan of x, right? That is equal to tan of pi upon 4 minus x, right? Any more times of this stuff. And okay, should we really write it as pi upon 4 minus x? I mean, okay, we don't have time for all that. In the appropriate thing, it works out. So we just say it's derivative of pi upon 4 minus x. Cool. Which is just -1. So D is the answer. In the end, what matters is you get the same result as what you would have got with the proper method, right? Because the result is going to be the same, right? It's just the general thing. I mean, the result is generalized. That's what I'm saying. It doesn't matter if you just do a special case and then get the result and then extend it throughout, because you can extend it, right? We know you can. Next question. 60, am I doing 65? Yes. Because rate of tan inverse of x is like 1 upon 1 plus x square, right? So it doesn't involve square roots and whatnot. And that's why it's okay to do this thing. Okay. 65th. The derivative of sine squared of cot inverse of, okay, whatever this thing is. Okay. Let's put I don't know, what should I say? Uh, yeah, just put x equal to tan theta. You know, this will just become, again, maybe not tan theta. That you got a square root, right? Oh, okay. Then let's put x is equal to cosine of 2 theta, right? Then this just becomes what? The square root of stuff, right? Square root of minus cosine of 2 theta upon minus cosine of 2 theta, which is 2 sine square of theta upon 2 cosine square. Yeah, like square root of that is just tan theta. So cot inverse of that is pi upon 2 minus theta. So sine square of that guy, sine square of pi upon 2 minus theta. That's like cosine square theta, sure. And then the derivative of cosine square theta, that's what we're looking for, I guess. Just 2 cosine theta, and then you got negative, and then sine theta. Cool. Yeah, wait, you're not looking for the derivative with respect to theta. No, you're looking with respect to x, right? Okay, the inside stuff is just cosine square theta, right? So d upon dx of cosine square, but then cosine square, that can be written as like 1 upon 2, and then you got 1 plus cosine of 2 theta, which is like 1 upon 2 upon plus x. So it's just 1 upon 2 plus x upon 2. So the derivative is just 1 upon 2. So that's B. Next question. 66th. If y equal to cosine inverse of 5 cosine x minus 12, okay, so 5 upon 13, 12 upon 13 are sine values. Sure. You can see this is cosine of x plus cosine inverse of 5 upon 30, right? That works. Okay. Yeah, that x belongs to 0 to pi upon 2. Then dy upon dx. Wait, you're looking for cosine inverse of that, right? Oh, sorry, you're looking cosine inverse of this whole thing actually. So you're saying x is an acute angle and then x plus this thing. Of course, this is actually just lying in 0 to pi, right? Because cosine inverse of 5.3 lies in 0 to pi upon 2. So there we go. Cosine inverse of cosine of this angle is just this angle itself. So x is cosine of inverse of 5 upon 13. Right. Then dy upon dx, that will just be 1. So A is the answer. Next question. Okay. Next. 67. uh, dy dx of tan square of 2x minus tan squared of x upon, okay, weird, using 2x over there. Is that right? Oh, I know what they're trying to do. It's this thing. It's tan of, we're just going to do it like this. Tan of 2x minus tan of x times tan of 2x plus tan of x, and then this thing upon, factorize that in the similar way, and then we'll put this over there, 1 plus tan of 2x tan of x, and then 1 minus tan of 2x tan of x, and then look at these guys. This thing is just brackets, whatever. This is just like tan of 2x minus x, which is tan of x, and this thing is tan of 2x plus x, which is tan of 3x. Okay, and that terms of cot of 3x, which, okay, with this just cancels, so it's just tan of x. So basically, you are doing the derivative of tan of x, which is what? Secant square x, right? Next question. Let's go to 68. If fx is equal to this thing, then what is this? F dash of 1 is equal to. Okay, it's interesting. Have I seen this somewhere? I don't know. Cot inverse. Can we write it like something related to cot? I don't know. X power negative x power x. Hmm. Where have I seen that? I have no idea actually. Wow, this looks really bad actually. Because, God, it's f dash of 1, we are saying. When you will put x equal to 1, this thing just becomes what, 0, right? Sure. Cot inverse. So the derivative of cot inverse of x, that is what, like negative 1 upon this x squared, I guess. Yeah. Because it's just pi upon the minus tan of x, so it works out. This negative 1 upon this x squared, but then x, in this case, okay, this inside stuff, negative 1 upon this inside stuff squared. This inside stuff is just going to 0, so it's just negative 1. All right, so negative times the derivative of this thing at x equal to 1, of course. Just hate this actually. So, okay, you might have x power x and then plus x power because you will have the exponentials repeating themselves, and then you will have the derivative of e power exponential log of x thing. This is so bad. So, right, you can write like e power exponential log of x minus e power negative exponential log of x upon 2, which, guess what, is just what, sine h of x. Okay, I don't think you know that, but yeah, the thing is like the derivative of this function. So like the derivative of e power x minus e power negative x upon 2, that's just equal to, this function is called sine h of x, and the derivative of that is cosine h of x, which is this function. I mean, that's actually pretty obvious, right? Anyway, once that's done, it's just like what, 1 plus 1 upon 2, so just that's 1. So like negative 1 times the derivative of this thing. Yeah, that looks cool. The derivative of this thing will just be natural log of x and plus 1. And you want this an x equal to what? 1. This will just be 1, right? Because this is 1. So it's just negative 1. That is what it's equal to. Yeah. So really, it's just A. Next question. Next we have 69th. If y equal to 1 plus x times 1 plus, okay, I think I've seen this expression a lot now, right? Just multiply by 1 minus x, just 1 minus x. Yeah, you get the thing. Just 1 minus x power 16 upon 1 minus x. That's what this expression is. So that's like a cheat code for expanding this out. Yeah, because this is just an AP, sorry, just a GP sum, right? This is just equal to 1 plus x squared all the way to x power 15. That's what this is going to be. Then dy upon dx at x equal to 0. Just 1, of course, because look at that. This is the only term that's giving us anything. Because everything else goes to 0. Like this has 2x and 3x and whatnot. It goes to 0. This goes to 0 as well, the derivative itself. Then derivative of x. That's all you get. Just 1 is the answer. So A is the thing. And do we really have to even find out the whole expansion? Just look at the linear term. What is the linear term in this guy's expansion? It's just x, because everywhere else, like you will collect terms, you're getting x squared, x power 4 and whatnot. So you need 1, 1, 1 from everywhere. Because otherwise you will have more than, the power will be more than 1 automatically. So you need 1, 1, 1 from these three brackets and then x from that bracket. So that's the linear term, just 1, x. Yeah. That's why the is just 1. Next question. If fx is equal to cosine of x, cosine of 2x, cosine of 4x, then f dash of 5 upon 4 will be. I think I've seen that as well somewhere. So you can multiply by sine of x and then also by 8. So just have this upon 8 sine of x, and then the 8 sine of x on the top. That will just convert this to sine of 8x. Yeah, you can do that. It's good. But like, how does this help? How does this help in figuring out f dash of pi upon 4? I don't know. Well, try to do it. Yeah, just try to do it, right? So you can differentiate the first one and whatnot. Okay, this is not gonna help. 5.4. Ah, fine. Let's try to do it. So just cosine of 8x upon, okay, that tens of 8, of course, just sine x, and then minus sine of 8x upon 8 sine square of x cosine of x, right? So when you will put x equal to what? Pi upon 4, sine of x of sine of pi upon 4 just 1 upon square root of 2. So that on the top it just becomes square root of 8, and then cosine of 8 times pi upon 4 cosine of 2 pi, just 1, minus this thing. So sine square of x is just 2, right? Sorry, 1 upon 2. So this just becomes 1 upon 4 in that case. Okay. Cosine of x, that is 1 upon square root of 2. So put that in there. Okay. And then sine of 8x, which is sine of 2 pi, right? That is 0. There we go. Square root of 2 is the answer. So A is the thing. Next question. This is 70, right? Next, let's go to 71. How much is remaining for this? Okay, till 80 only, right? It's 10 more questions. 71. If x e power x plus y is equal to y plus 2 sine of x, then at x equal to 0, dy upon dx will be. Okay. I just hate this kind of thing. Was why? Why are you doing this? Ah, then at x equal to 0, dy upon dx is. Mm. I mean, even then you will just differentiate everything. So when you will differentiate e power x plus y with respect to x, of course, you will end up getting e power x plus y times 1 plus y dash, but then you will still have this x on the front, so that will still completely vanish. So all you care about is just e power x plus y. It's like e power. Okay, wait. What is y at x equal to 0? We don't know. It's called like y naught, y at 0, right? So that will be the term that you will care about on the left hand side in the derivative. And then, right, y dash at 0. Okay, so y dash at 0. And then plus 2 sine of x. So just 2 cosine of x at equal to 0 is just plus 2. That makes sense. Okay, now you need to know what y at 0 is. When you will put x equal to 0, yeah, okay, y becomes 0. Fine. What that means is just have e power 0 with it. Just 1. 1 equal to y dash plus 2. So y dash equal to negative 1, which is A. Next question. 72. 72 is if sine of 3x minus y, sorry, 3x minus 2y is equal to log of ln of 3x minus 2y, then dy upon dx is. Okay. This is really bad. Uh, wait a second. This is like saying sine of u is equal to log of u, where u is just 3x minus 2y, right? Yeah. So when does this happen? Sine u equal to ln u? Uh, let's graph them out actually. Sine u is like this, and so yeah, like at x is equal to pi, it will become 0 the first time, and then ln u. So 1 is very less than pi, I think. Okay, so it's like this. That's what ln u looks like. So as you can see, there's only one intersection point, which is at this point, right? Yeah, and do I really have to tell you about derivative of these guys? In the derivative of this guy is 1 upon u, and the derivative of this guy is like cosine of u. And yeah, you can do the thing like, is this bigger than 0 or less than 0? As you can see in this region after the intersection point, it's just like these are just increasing. The difference, sorry, the difference is increasing, right? And in this case, the difference was okay. It was like really negative actually. So yeah, I mean the difference must be negative. Oh, the difference must be increasing all the time, right? Because this was negative at that point. Okay, so the thing is like 1 upon u minus cosine of u. That is the derivative of fraction log of u minus sine of u. So the rate of the difference. I mean how the difference is changing. It tells us that, right? So u is positive all of the time. Okay, right. When u is less than 1, you don't have to care about anything because 1 upon u is already bigger than 1. So it's, yeah. And when, yeah, like after that, so when u is more than 1, what is the thing? What is this going to be? Um, it's kind of complicated actually. But you can see from the graph itself that it can only intersect at 1 point, right? Yeah. How do I explain what is supposed to happen? So when u is more than 1, okay, it's really hard to explain what's going on. Hmm. I'll have to show that this is still positive. But how? Staying on the derivative, of course. Negative 1 upon u squared plus sine of u or something. Okay, it's not helping. It's not helping. You could take another derivative. So just 2 upon u cube plus cosine of u. And now this thing, okay, that works out. Or so it seems. No, it won't work out. It was like this will change its sign. Ah, now this is just too much. Okay. So when u is more than 1, it's kind of a weird thing happening over there. Oh, what I drew is not ln x. Is it? Yeah, it is in fact ln x, right? Yes. Yeah, ln x does look like, and this is a wavy function, whatever. It is like bounded, right? Ln x is a increasing function. That's what we care about. So after some point, we'll be like more than 1. When is that point going to happen? At e, of course. So e is 2.7 something, and then pi is 3.14. So before pi, it will become more than 1. All we have to show is that before e, uh, the difference was completely increasing. Why do I even have to show anything? Because we can already see the graph tells us, I mean, that it's going to intersect at a single point. So no need for showing anything. You know how the graph should look. If you really want that kind of analysis, just do it yourself. Yeah. So there we go. What we just figured out is that there's only one point where this intersects, which is, I don't know what point it is, but the main point is that it's a single point, which means like what is going to happen is that x minus 2y is some kind of constant. That point, of course, the value of u where this happens. So 3x minus 2y is equal to whatever value of u was where this is happening. Okay. Yeah, that's the thing. So what's dy upon dx? It's just like 3 minus 2 y dash is equal to 0. So y dash is just equal to 3 upon 2. There we go. That's our answer. So it's A. Nice. Next question. 73. Wait, even if this was like at 2 points, so it was intersecting at 2 points, would it really matter? Because 3x minus 2y would just be one of these 2 points, right? Yeah. Oh, you should have done that in that case. Whatever. So there was no need for proving that there's a single point where this happens, but then okay, you would have actually two different curves, and but we have two different values of y for the same x a lot of times, right? So why do you even care about that? I don't know. Next question. 73rd. If x power 4 plus y power 5 equal to 2, x plus y power 9, then the value of dy upon dx is, oh yeah, okay. So notice this is homogeneous, right? What you can just do is put y equal to kx. What that will do is we'll set up this equation. K power 5 is equal to 2 times of 1 plus k power 9. So this is a polynomial equation. It will have some values of k, right, which will be constants. Right. What that means is like dy, yeah, like the y thing is just kx, where k is a constant. So dy upon dx is just k, which is also y upon x. So dy upon x to y upon x. That's our answer. I know this is going to have like 9 roots, right? Uh, at max 9 roots, but we don't care. We really just don't care that it's 9 different roots. Yeah. Okay, next question. 74. If x is equal to this thing, okay, theta sine theta, okay, and y is equal to this thing, then dy upon dx. Come on, seriously. Why do you have to do this? Okay, fine. Yeah, I'll just have to do it. Fine. So dx upon d theta. Okay, first of all, dy upon d theta. And that a is still there. Okay, skip that a stuff because that's just a constant. It comes out, and then we don't need that. So it just cosine, and then you got minus cosine, and then plus theta sine upon negative sine, and then plus sine, and plus theta cosine, right? So just tan theta. That's what dy upon dx is. Next question. 75. If x is equal to this thing and wait, sorry, what? Cosine of x is equal to this thing and sine of y equal to that, then dy upon dx is. Wait, so these are the same values? Okay, no, that's t over there. Okay, fine. Oh, so you are saying, wait, what? But this thing is actually just sine of x. Isn't that right? Okay, or mod of sine of x. That's what I should say, or something like that. Whatever. Um, yeah, so just have cosine square x plus sine square y equal to that. Yeah, like that just means cosine square x is equal to cosine square y. Then what's the There's not a lot of ways that this could happen. The way this would happen is if you have y is equal to x plus minus pi upon 4, right? Sorry, what am I doing? Plus minus n pi. That's what I should have done. Y equal to x plus minus n pi or something else. Wait, I'm doing something really wrong. What was the thing? Cosine square y equal to cosine square x, right? Oh, then it's just y equal to n pi plus or minus x, of course, right? That does it. So the slope would be 1 or minus 1. So it's a and b at the same time. That's not good. Okay. Okay, this is just not good. 1 minus t upon plus, I don't think that's correct. 1 upon plus t square. I mean, does it matter what the value of t is? No, it doesn't. So, okay, what the sine of t is, that could matter. Oh God, moreover, you will have like, because cosine x, so x could be the negative of what we think it is, and then it still works. So really, there are actually two slopes. It's 1 and minus 1. Okay, so it's A and B. Next question. But this is not multiple choice. Is this? Who knows? 76th. X is equal to this thing. Okay, x is equal to cosine of tan inverse of t or whatever. Y equal to sine of, you get the thing. Then dy upon dx, right? So y is sine theta, x is cosine theta. That's all you need to do. Then it's just what cosine theta d theta upon, well, dx will just be negative sine theta d theta. So just negative cot theta, or I should say cot of 2 theta or whatever. Nah, cot theta. So, which, I mean, you already know the thing, right? Cosine theta is the same thing as x, and sine theta is the same thing as y. So this just really is negative x upon y. Yeah, of course. So the answer will be C. Next question, 77. If y equal to this thing, then dy upon dx is. Oh God. This doesn't look good. Okay, so the thing is y is equal to square root of, so like, let's replace x by, okay, we should not do that because we want everything in terms of x, huh? Oh God. Fine. So y equal to square root of x plus 1, and then that other stuff is just y, isn't it? This is not going good. So like y square is equal to x plus 1 plus y, which means y squared minus y um, minus x minus 1 is equal to 0. Okay, the discriminant is somehow, so if you assume that x is positive, or like 1 plus x is positive, then fine, it has two solutions, and one of them is positive, and that explains what y is. Of course, it's dependent on x, right? Yeah. I just don't know whether or not this kind of treatment is actually correct. But then whatever. We don't really care about the rigor of our answers, right? So just dy upon dx, just figure that out. So like 2y y dash minus y dash is equal, okay, minus 1 is equal to 0, which means y dash is just equal to 1 upon 2y minus 1. There we go, that's our answer. Yeah, so just 1 upon 2y minus 1, which is D. Next question. 78. If y equal to this, what is this? Seriously, why are they doing these kind of things? Okay, now just put x plus 1 as u, then this is like y equal to u power y, and what you really want is just 1 minus natural log of y times u, and that times of dy upon dx, right? This is our, or dy upon dq, because du and dx are the same thing. This is what you look for, right? Okay. So right, what was I doing once again? Yeah, okay, just try to solve this thing. So you can just take a natural log on both sides. You just have natural log of y is equal to y natural log of u, and then take the derivative. So 1 upon y dash is equal to y dash natural log of u plus y upon u, right? Okay, so like y dash is just equal to, or I should say y dash times 1 upon y minus natural log of u is equal to y upon u. And what do you want, by the way? What you want is 1 minus natural of, oh god, that should be different. There's no 1 upon y over there. You just want simply 1 minus natural of y in that terms of this thing. No, that's not going correctly. Wait, why did this happen? And that's y for sure, right? So it's just x, sorry, it's just y equal to u power y, and then just get like natural log of y equal to y natural log of u. Then this should have worked. 1 upon y. What's going on? Why did I get that thing? It's not having, oh, this is natural log of y, not natural log of u. Oh, that explains a lot actually. Okay. So, yeah, right. Natural log of u, you can replace that by 1 upon y natural log of y, right? So it just becomes y dash upon y, 1 minus natural log of y, minus of u, of course. That's equal to what? Y? Yeah. Just equal to y squared. I mean, this whole thing is just equal to y squared. That looks cool. So B is the answer. Next question. 79. Um, seriously, are they just going to do this forever? Okay, and another one of these guys. Fine. Y equal to x squared plus 2 upon, okay, whatever. So like y is just equal to x squared plus 2 upon y, right? Then what's dy upon dx? You don't even know whether or not these kind of infinite things are going to converge or whatever, but just do it. Fine. So it seems like y squared is equal to x squared. You know what? No, no, just don't do it like that. We'll just say y minus 2 upon y is equal to x squared. Yeah. Then, okay, the derivative will be like 1 plus 2 upon y squared times y dash equal to x squared. So y dash is just x squared times again x squared y squared on y squared plus 2 y squared, sorry. Uh, that's not here. Why is that not here? Okay, this is different than what I thought. Oh, I think I know what they're doing. Fine, 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 fine. So like 2 upon y squared, right? Plus x squared upon y is equal to 1. You can use this to reduce this a bit, I think. So basically like 2 upon y squared plus 1. Okay, that's different. This would just be this thing, 2 minus x squared upon y, and the rest of y dash is equal to x squared. So y dash is just equal to, okay, you still have this square stuff, and I don't like that. should only have x, not this. What happened? Oh yeah, okay. The derivative of x was supposed to be 2x. Okay, that's what's happening. That's the problem. Okay, this should have the thing. Yeah, cool. Uh, right. Now what does that mean? Um, y dash is just equal to 2xy upon 2y minus x squared. Cool. Um, which is, it's plus, right? No, no, it's minus, of course. So this, right? A is the answer. Next question. 80. 80 is y equal to this thing. Then once again, let me guess, you want dy upon dx. So e power 2y plus e power 5. Just y equal to e power. Wait, okay, x is given as a function of y, fine. Or it's not exactly a function, it's whatever this thing is. E power 2y plus, like, this thing is just, once again, just x, right? Yeah. So natural log of x is equal to 2y plus x. So basically, y is equal to 1 upon 2 natural log of x minus x. Then you want dy upon dx. That's just 1 upon 2, and you got 1 upon x minus 1, which is 1 minus x upon x. So 1 minus x upon 2x, which is C. So next question. Okay, there's no next question. That's it. This is done. So let's check this. So we want from 41. Okay. Wait, was that answer or something? Oh yeah, right. So 41, that is here. BAB 44th. DCA 7. DBD 50. CCBCC. Okay, interesting. C. Okay. 55. BDBB. Oh, 55 is B. Okay. 56 is D. 7B, then B, then B. Wait, 59 is B. Oh, 60, 61C, then AA, then 54, DBAC, 68, AAA, 71, ATC. Oh, 72 is okay. 73C, 24th, PD. So D is correct apparently, and A is incorrect. Huh. Okay. 76. 76 is C, then D, then B, then 79 is A and C. Okay, fine. So let's go to 72. Oh, where is it? 1A exercise. This is exercise 1A. Yeah, so we want, actually, since we are on the top anyway, start from 41. So the first question that went wrong is 53. Okay, that was so like we already knew there was no such f, and that's why I'm gonna say their answer is wrong. Okay, 55. So it's B, not D. Once again, I don't know how they got 7 upon 8. Like, what went wrong exactly? Okay, let's just do it once again. So you have 5 f of, okay, it's like 5u plus 3v is equal to 2x plus 2. Then you have 5v and 3u. that's equal to 2 upon x plus 2. So first you just add, and you will get like 8 times of u plus v. That's equal to 4 plus 2x plus 2 upon x, which means that u plus v is equal to 1 upon 2 plus x upon 4 plus 1 upon 4x. Then you will subtract. So 2 times of u minus v is like u minus v is just equal to, that 2 is going to get cancelled in any way. So it's just x minus 1 upon x, right? Yeah. And then what? So we want u, for which you just take the average or something. So 1 upon, wait a second. How did that happen? Oh, that's not good. 1 upon 4. Last time I saw we got something else, right? Oh, I must have put a negative. Okay, okay, that's what went wrong. This, these twos get cancelled, right? So, uh, yeah, if there was some constant over there, then that was wrong. Okay, let's do it properly this time. So it's 1 upon 4, and then you got subtract from there. 1 upon minus 1 is just 3/4. So it's negative 3 upon 8x. Okay, then subtract, so basically like add. Yeah, because we're just trying to u, right? Uh, I guess, yeah, that is the thing. So when you will subtract, no, you sorry, you're adding, right? Yeah. Oh God, you're adding. What am I doing? Okay, so it's x plus x upon 4. Oof, okay, I think that's what this, I think I replaced that by 1, which is wrong, of course. So this must have been the mistake that I did, right? Okay, so you will just have 5x upon 8. Okay, and then you will add this, so just negative 3/4 upon 2 is like negative 3 upon 8x. That is our u, which is f of 2x. So f of x is just 1 upon 4 minus 5x upon 16 minus 3 upon, what's this, 4x, so just 2x. Yeah, that's what f of x is. So what do you want? Just x times of that? So like y is just x upon 4 minus 5x upon 16 minus 3 upon 2. So then you want dy upon dx of this thing, which is just 1 upon 4 minus 5x upon 8. And you want the x equal to 1. So 1 upon 4 minus 5 upon 8, that's like 2 upon 4 minus 5 upon. Oh, that still didn't work out, huh? Okay, now what went wrong? This went wrong, okay. I mean, you had to add, no, that is fine, no big deal. Negative 5x upon 8. Okay, okay, okay. This and that is supposed to be positive, right? Yeah. Okay. Then you got 5x upon 8. We'll just put x equal to 1. So 2 upon 8 plus 5 upon 8, that's 7 upon 8. That's why B is correct. Huh. Fine. So 55. This really is correct. Okay. Then 59. So if fx is equal to log base x of log x, then f of x at x equal to e is. They just want f of x. They don't want f dash. Okay. So yeah, just put e in there. It's like what? Log base x of 1, which is like log base e of 1, which is 0. So it really has to be 0. So their solution is just wrong. I know what they're trying to do. They should have put f dash of x, not f of x over here, right? That would have made more sense because it's differentiation, right? That's what we're doing. So the differentiation of this thing, let's do it the proper way. Natural log of x upon natural log of x, the derivative of this thing, right? So that will just be what? Uh, yeah, like 1 upon natural log of x, and then the inside of just 1 upon x, and then you got my natural log of x already. Yeah, of course. And then the rate of this guy, which is just natural log of x upon natural log of x squared negative, and then rate of this guy just 1 upon x. So you want this at x equal to what? X equal to e, right? You just have 1 upon e outside, then you got 1 upon, this is just 1, this is also 1, just 1 minus, this is 0 because like natural log of 1 is just 0. So yeah, This is the thing. It's just 1 times 1 upon e, which is just 1 upon e. So that's why B would be the answer if this was actually f dash of x. But then it's not. So it's none of these. Right. Okay. Next, what went wrong is 72. Huh? Okay, can be that one. So D is the thing is negative 2/3. So 3x minus 2y is some kind of constant. Then 3 minus 2 y dash is equal to 0. It should really just be 3 upon 2. 3 upon 2 is dy upon this. I don't get it. How did they get negative 2 upon 3 for this? It doesn't make any sense. This is so simple. The slope of the line is just 3 upon 2. So dy upon dx is 3 upon 2. Right, their answer is wrong. Okay. And then 75th. So they are saying it's just D. Of course, they are wrong. It's both A and D because it really depends on what T is. And yeah, so like cosine x is equal to 1 upon square root of. This has two different solutions, or actually not two. You have multiple solutions, but then those two matter because they are the okay. Like you just need two solutions because you just need to know whether it has a positive or a negative or something like that, right? So is it positive cosine inverse of this thing or negative cosine inverse of this thing plus some constant, of course. You will have to see that, right? So of course it's both of these things, 1 and minus 1. That would be the slopes. Right. And nothing else went wrong. That's it then. So I'll see you guys in the next video.